I'm Satya, representing from KCS Kosinadar College of Arts and Science, going to cover some important topics on software engineering. Why software engineering? This is the picture. It shows that the people who are working as a team in a development of software product with a different aspect in viewing the problem. The customers or the end users explain what he needed in software product. The project manager, engineer, technician look over the problem in their own views and finally they get an inefficient product. To avoid this, the team members working under a project should maintain a documentation in each and every phase. And the document are carried out throughout the life cycle of software development. And if any changes made in phase could be updated in the previous phases so that an efficient software product should be produced. The definition of software engineering is it is a technological and managerial aspect of discipline concerned with systematic production and maintenance of software products that are developed and modified on time and within the cost estimate. Software is more than just a program code. Along with the code, it is associated with libraries and documentation. Overview of software development life cycle. Here there are 5 phases. The first one is the analysis phase. Requirements are gathered from the customer. The customers are the client or the end users who is going to use that software. Next is the design phase. Here, the requirements are converted into proper design by some designers. Following that, the implementation phase. In the implementation phase, the designs are converted into coding by technician people. After that, the testing is done to check whether the written coding is working properly or not and whether it satisfies the customer requirements. If testing is okay, then the product is ready to use. In future, if any issues or enhancement is needed, then the maintenance is done in the project. The second phase is the software design. If it is a good design, then it's clarify the interrelationship. If it is poor, then it is complicated. There are 3 levels of design notations are here. The first one is the external design, then architectural design, detailed design. The architectural design and detailed designs are collectively referred as the internal design. External design, it shows the external characteristics of a software system. The architectural design, it is a structure. In detailed design only, the control flow, data representation and other algorithmic details within the modules are prepared. These are the concepts in software design. Abstraction, it is an intellectual tool that deals with a particular instance. Information hiding, it hides the internal details of the processing. Next, structure, it decomposes a very large system into smaller one. Modularity, the smaller one decomposed system is a module and it can be assigned for an individual programmer for development. Concurrency, that individual module can be activated simultaneously. Verification, design is a bridge for verification. Verification means it checks whether it satisfies the customer needs or not. Aesthetics, it should be good in elegance and clarity. Modularization, it is a process of dividing a software system into multiple independent modules. Each module can work independently. The advantages of modules are it is very easy to understand the system maintenance is easy, and reusability is one of the main advantage of modules. Coupling, it is a degree of interdependence between software module. Content coupling, when one module modifies the local value of another module, then that is known as the content coupling. Common coupling means 2 modules can be bound together by one global data structure. Control coupling, when one module controls the another module by using some control flags. Stamp coupling, it's similar to that of the common coupling only, but the global data items are shared selectively among the routines when they require the data. Data coupling means use of parameter list to pass data items between the routines. Cohesion. Cohesion refers to the degree to which the elements inside a module belong together. Coincidental cohesion. The elements in a module have no relationship to one another. Logical cohesion means there is some relationship among the elements of the module. Temporal cohesion means logically bounded modules are known as temporal. Next, communicational cohesion. These refer to the same set of input or output data. Sequential cohesion. When the output of one element is the input for the next element, it is referred as sequential. Functional cohesion means type of binding of elements in a module. Information cohesion means when a module contains a complex data structure and several routines to manipulate the data structure. Design notations. There are various design notations used for designing: stepwise refinement, level of abstraction, structural design, integrated top-down development, finally Jackson structure programming. These are the various notations that is used for designing a software. Here bottom-up approach and top-down approach are used. Important university questions that are frequently asked: design techniques, coupling cohesion, and then design notations, fundamental design concept, structured design, top down development design, modules and modularization criteria, design guidelines, abstraction of design concept. These are the questions frequently asked in the software design concept. Thank you for all.